Welcome to Arsenal, where the weapons and war machines of military history come to life. Today, we explore the SR-71 Blackbird in Cold War Strategic Reconnaissance and the crews and opponents who gave it its reputation. If you enjoy learning how technology, tactics, and human decisions come together in combat, you can find more articles, podcasts, and resources at trackpads.com. Dawn is just breaking over the Pacific as the Blackbird roars down the runway at Kadena, afterburners thundering against the humid air. The long, black aircraft lifts clear of the concrete, tucks its landing gear, and starts a climbing turn toward the coast of North Vietnam. Inside their pressure suits, the pilot and reconnaissance systems officer trade clipped phrases while the Mach meter creeps upward and the sky deepens from blue to near black. One small crew rides a very fast arrow.
High above 80,000 feet, warning lights flicker as enemy radars search for the intruder far beyond normal airliner altitudes. The crew watches as launch indicators confirm that surface-to-air missiles are rising from batteries below, bright dots on a panel rather than white plumes in the haze. Standard practice is not to jink wildly, but to lean into the aircraft's nature, to climb slightly and push the throttles while holding a precise track. The goal is to outrun the missile envelopes rather than outmaneuver individual shots. Arsenal is the Friday feature of Dispatch, United States military history magazine. On runs like this, the Blackbird proves that speed and height can still carve out a narrow lane of relative safety.
The SR-71 was built to answer a problem that became painfully clear when a high-flying U-2 was shot down over the Soviet Union in 1960. Leaders in the United States realized that altitude alone no longer guaranteed survival against modern radars and guided missiles. At the same time, they needed regular, detailed imagery of missile fields, bomber bases, naval ports, and troop deployments deep inside countries that would never allow overflight by conventional aircraft. Early reconnaissance satellites were promising but limited, locked into fixed orbits and not always overhead when crises flared. Commanders wanted the ability to point a sensor platform, like a camera, send it toward a target, and have answers on their desks within hours. Strategic vision demanded a machine that could ignore most borders.
From this need emerged a daunting set of technical demands that few aircraft could hope to meet. Any new reconnaissance platform would have to cruise for long periods at speeds above Mach 3, while remaining controllable and reliable enough for regular operations. It had to fly higher than most missiles could easily reach, yet still carry heavy cameras, side-looking radar, and electronic receivers over intercontinental distances. It needed to operate from secure bases, link up with tankers, and return film and data rapidly to interpretation centers. Existing bombers, fighters, and converted transports were too slow, too vulnerable, or too limited in sensor capacity. The answer would not be a modest upgrade of an existing airframe. It would be a purpose-built machine designed from the outset to live at the edge of the stratosphere.
The design story behind the SR-71 began with the earlier A-12, a single-seat aircraft developed for the intelligence community. That program showed that a titanium airframe with sharply swept wings and powerful afterburning engines could survive the skin temperatures and aerodynamic loads of sustained high-speed flight. When the United States Air Force sought its own version, engineers reshaped and stretched the concept into a two-seat strategic reconnaissance aircraft with more internal volume for fuel and sensors. They accepted the difficulty of working with titanium because aluminum would simply soften at the anticipated skin temperatures. Every major choice involved clear trade-offs. Strength and heat resistance came with manufacturing headaches. The Blackbird's long, dart-like fuselage and distinctive chines were shaped to reduce drag, provide lift, and help manage radar reflections.
Its huge J-58 engines were tuned for high-speed efficiency, relying on complex inlets and bypass systems that made them behave partly like ramjets at cruise. On the ground, these same engines demanded careful handling and meticulous maintenance. At a glance, the SR-71 was a twin-engine, two-crew strategic reconnaissance aircraft built by the United States for the United States Air Force during the Cold War. In practice, it was closer to a crude high-speed reconnaissance system than a simple airplane. Each aircraft was almost hand-built, emerging slowly from specialized facilities that had to learn how to shape and join titanium like a daily craft. Walking around the Blackbird on a museum floor today, visitors notice its size and its uncanny lines. The nose is long and narrow, the chines blending into the fuselage like the edges of a knife. The engine nacelles bulge outward, ending in pointed cones that once slid forward and back to manage shock waves at different speeds. Panel lines and access doors mark where cameras, sensors, and maintenance points once hid beneath the black paint. On the ground during its service years, fuel often seeped from seams that would only seal when the skin heated and expanded at speed. It looks alien because it was built for an environment most aircraft never reach. Climbing the ladder into the forward cockpit put a pilot into a world that resembled a cross between a fighter and a spacecraft. The ejection seat, pressure suit connections, and framed canopy spoke to the dangers of high-altitude escape. Instruments mixed familiar gauges with specialized indicators for Mach number, true airspeed, and engine inlet behavior. At cruise, the pilot's job was to hold the aircraft within a narrow band of speed, altitude, and angle of attack, managing fuel balance and throttle settings to keep the engine stable. Behind, in the rear cockpit, the reconnaissance systems officer sat in front of a dense panel of controls. This crew member managed cameras, radar modes, navigation updates, and communications along the entire route. A typical mission unfolded in distinct phases that demanded tight coordination between the two crew members and the ground teams that supported them. After takeoff and initial climb, the Blackbird would rendezvous with a tanker to top off its fuel before accelerating into its high-speed profile. Once established at altitude and speed, the pilot focused on precise track keeping, while the reconnaissance systems officer synchronized sensor operation with navigation waypoints. Over targets, cameras and other sensors gathered data in tightly timed sequences. On the return leg, there were more tanker hookups, then descent and landing at a prepared base where specialized crews waited. One short burst of speed produced hours of work for analysts. The Vietnam War era provided the SR-71 with its first sustained exposure to dense, hostile air defenses. From bases in the Pacific, Blackbird crews flew missions that traced supply routes, photographed airfields, and mapped surface-to-air missile networks. Warning systems lit up as enemy radars tracked the aircraft and missiles launched from below. Rather than trying to twist and turn away from each shot, crews used subtle climbs and power changes to stretch missile trajectories until guidance could no longer keep pace. The aircraft's speed and altitude did the hard work. Film and sensor data from these sorties fed directly into strike planning, route selection, and assessments of bombing campaigns. For those who relied on its output, the Blackbird's strengths were obvious. It could cover hundreds of miles of hostile territory in a single high-speed run, producing imagery that showed not just individual targets, but how entire systems connected. Its survivability in the face of modern air defenses made it a trusted tool in crises when up-to-date intelligence was crucial. Adversaries recognized that its presence meant their most sensitive sites could be photographed in detail, adding psychological pressure to keep air defenses on constant alert. However, the aircraft also brought tangible burdens. It was costly to operate, required rare materials and expert technicians, and depended on a chain of tankers and support aircraft to complete its missions. Complexity was the price of its capability.
Within the broader family of high-speed aircraft, the SR-71 sat alongside the earlier A-12 and the experimental YF-12 interceptor. The A-12 had already flown dangerous reconnaissance missions, while the YF-12 explored the idea of matching the airframe's performance with long-range air-to-air missiles. The SR-71 became the main operational workhorse, with the A model dedicated to strategic reconnaissance and a small number of B and C models used for training. Over time, most changes focused on its internal systems rather than major structural redesigns. Cameras gained better resolution, radar acquired finer mapping ability, and electronic receivers improved their sensitivity and recording methods. The basic silhouette of the Blackbird remained constant, even as its internal electronics modernized.
As satellites became more capable and numerous, and as other manned and unmanned platforms grew into parts of the reconnaissance mission, arguments over the SR-71's future became sharper. Supporters pointed to its flexibility, speed, and proven track record in multiple theaters. Critics emphasized cost, maintenance demands, and the risk of relying on a small fleet of aging airframes. Eventually, budget decisions and changing concepts of operations pushed the Blackbird out of frontline service. It left not as a defeated platform, but as one whose specialized niche had narrowed in a world where space-based eyes and other sensors filled more of the map. Today, SR-71s rest in museums and collections across the United States, their black paint dulled by time, but their presence still striking. Visitors can walk beneath their wings, study the heat-rippled skin, and peer into cockpits that once climbed into the thin blue above most of the atmosphere. Displays often place them within the wider story of Cold War tension, nuclear standoff, and the ceaseless drive to see over the next horizon. For readers and listeners who follow dispatch and trackpads, the Blackbird connects naturally to stories about bomber crews, missile fields, and long-running reconnaissance efforts. The machine reminds us that information can be as decisive as any bomb or shell. Behind every SR-71 mission were people whose lives and careers turned on the aircraft's performance. Pilots and reconnaissance systems officers trained for years to master its demands, knowing that mistakes at those speeds and altitudes left little margin for recovery. Ground crews wrestled with specialized fuels, delicate sensors, and heat-stressed components to keep the aircraft ready. Analysts pored over film and electronic traces to turn raw data into insight. Each of them contributed to a chain that linked one flight to decisions made far away. In that link between steel, fuel, skill, and judgment, the Blackbird earned a place in the arsenal of strategic reconnaissance that cannot be measured by numbers alone.